welcome to the NAMSIN channel. And today we'll be looking at trigonometry. Now we're going to solve these questions we have here. We'll be able to run down these by the end of the tutorial. Okay, so now let's get started very quickly. Trigonometry. Now, trigonometry is founded on right-angle triangles, and so we cannot talk about trigonometry without considering right-angle triangles. And we already know some of these things, or most of these things. Now, we have the right angle triangle, because this is 90 degrees, and we have our angle theta, the angle of inclination. So we express our angles, we work with the quotients of the sides of the triangle. So we consider sine, cosine, and tangent. Now sine theta is given by opposite over the hypotenuse, which is y over r, as we see. And then cosine of theta is given by the adjacent over the hypotenuse, which is x over r, as you can see. And then the tangent of theta is given by the opposite over the adjacent, which is y over x, as you can see. Now the tangent is also given by the sine over the cosine. That's tan theta is sine theta over cos theta. And this shows it when you have y over r dividing x over r, brings us back to y over x. Now, we have the inverse trig ratios as well. So, cosec theta is 1 over sine theta. That gives us r over y, as you can see. Sec theta or secant of theta is 1 over cos theta, gives us r over x. And then cotangent of theta, cot theta, gives us 1 over tan theta, and that gives us x over y, as you can see. Now we have identities, trig identities, and the trig identities are founded especially on this particular identity. Now sine square theta plus cos square theta will give us 1. Now it's easy to show that from here. If you square this and then you square this, you add them together, you find out that you'll be having y square plus x square over r square. And if you remember Pythagoras, x square plus y square is going to give us r square. So in the end, we'll have r square over r square, which is 1. Now we can show that, but this is the base identity from which you can get other identities. And to demonstrate that, I've added another identity here, and we got this by dividing through by sine square theta. So when you divide this by sine square theta, you have 1. Divide this by sine square theta, you have cot square theta, because cot is going to be 1 over tan, which is cos over sine, like we've shown, and then 1 over sine square theta gives us cosec square theta. Now we also have sum of angles, and we can have trig ratios of sum of angles, and it becomes very useful in the study of trigonometry. And so I've just stated a number of them that are useful and will be very useful for us in this topic. Now sine of alpha plus beta is given by sine alpha cos beta plus cos alpha sine beta. There's a swap here, so just understand this and you'll be fine. Then sine of alpha minus beta is sine alpha cos beta minus cos alpha sine beta. Now the cosine of alpha plus beta gives us cos alpha cos beta minus sine alpha sine beta. So it's cos and then sine. Then cos of alpha minus beta gives us cos alpha cos beta plus sine alpha sine beta. Now cos is usually very unique. Now when we consider cos, there's usually a swap of signs. So if you take note of that, it will be helpful. Now it's easy to reproduce these. Yes, don't stress too much about it. Just understand it. It's easy to reproduce. Then tan of alpha plus beta will give us tan alpha plus tan beta over 1 minus tan alpha tan beta. Now tan of alpha minus beta will give us tan alpha minus tan beta over 1 plus tan alpha tan beta. Now, just like the cosine, there is a play on the signs here. So you need to understand that the denominator, the sign you have at the denominator is opposite of what you have at the numerator and also in the parentheses. So with this, we can go on to solve these questions. And so we'll begin the solution to these problems now. So, solution. So 1, you have sine 225 degrees. So we're told to evaluate without the use of tables or calculator, and we have to evaluate sine of 225 degrees. Now observe that in this diagram which I drew here, I added extra or additional information. Now we can split this into quadrants. Now a quadrant is 1/4, so we've split this plane into 4, and this is the first quadrant. The first quadrant is from 0 degrees to 90 degrees, as you can see here. And then the second quadrant is from 90 degrees to 180 degrees, as you can also see here. The third is from 180 degrees to 270 degrees, and the fourth is from 270 degrees to 360 degrees. Now the total gives us 360 degrees, and so that's why we can also consider this as a circular function. It's a circular function. So now theta, we can also express higher angles in terms of smaller angles. It becomes very useful. And so if we work with the fact that theta is always between 0 and 90 degrees, then it means that any angle within the first quadrant can be represented as 90 degrees minus theta, where theta is another angle which is between 0 and 90 degrees. And then any angle in the second quadrant can be expressed in the form of 90 degrees plus theta. Recall that theta is always between 0 and 90 degrees. And then any angle within the third quadrant can be expressed as 180 degrees plus theta. And then any angle within the fourth quadrant can be expressed as 360 degrees minus theta. And it becomes very useful because if we can express angles in any of these forms, then we can evaluate the sine, cosine, or tangent of those angles in this quadrant by just evaluating that of theta. Now, I've said many things, but when we take examples, you'll understand. I want you to also note that there's a sign convention. Here, all functions are positive. That's, you have sine, cosine, and tan. They are all positive here. And then in this place, all of the sine functions are positive. And here, all of the tan functions are positive. And here, all of the cosine functions are positive. Understand that? Now, we can evaluate the cosine tangent functions here as well. But the only thing is that they will be negative. So let's evaluate sine 225 degrees. First question is, where does 225 fall in this quadrant? Now 225 is between 180 and 270. So that means that we express this as sine of what? 180 degrees plus theta. And what's our theta? We have sine of 180 degrees plus 45 degrees. 45, theta is 45 degrees because that's what will give us sine of 25 degrees. And so we can simply evaluate this as sine 45 degrees, which is sine theta. However, we need to consider, is sine positive in this quadrant? No. Only tan is positive in this quadrant, and so we have to add a negative sign to this. And so sine 225 degrees is equal to minus sine 45, and minus sine 45 has a value of minus 1 over root 2, which we can write as minus root 2 over 2 when we rationalize. And with that, we've solved this question. Then we'll move on to 1b. So, and we have to evaluate cos 75 degrees. Cos 75 degrees. Here we are going to use sum of angles. Now, recall that cos 75 degrees can be written in terms of other familiar angles as the cosine of 30 degrees plus 45 degrees. Now, if we consider this to be our alpha and this to be our beta, it means that we are having cos of alpha plus beta. And if we write that out using this identity, we have that cos of alpha plus beta will give us cos alpha cos beta minus sine alpha sine beta. And so our alpha is 30, beta is 45, so we have cos 30 degrees multiplying cos 45 degrees minus sine 30 degrees multiplying sine 45 degrees. And so we evaluate this very quickly and work with brackets. Cos 30 degrees, and our cos 30 degrees will give us what? Root 3 over 2. And then what's our cos 45 degrees? Our cos 45 degrees, we rationalize that is root 2 over 2. Then minus, then our sine 30 degrees, that's 1 over 2. And sine 45 degrees, also 1 over root 2, but when we rationalize, that's root 2 over 2. Evaluating very quickly, we have root 6 over 4 minus root 2 over 4. That gives us root 6 minus root 2 over 4. And you can leave it at this because the sorts are different. So, go on to question number 2. A, we have to evaluate sine 22.5 degrees. Now, sine 22.5 degrees, actually, note that 22.5 is half of 45. So 22.5 degrees is half of 45 degrees. In other words, we can say that 45 degrees is 2 times 22.5 degrees. Now, we need to evaluate the sine of this. And so we can look at, we need to consider double angles or a sum of angles. Now, a special case of sine alpha plus beta is where alpha is equal to beta, which means we have sine 2 alpha. And when we have sine 2 alpha, okay, we have, okay, it will be best we use cosine. And I'm going to explain why we have to use cosine. Let me write this out. Sine 2 alpha is equal to 2 sine alpha cos alpha. You'll be able to show that. And then cos 2 alpha will be equal to cos squared alpha minus sine squared alpha. Now, because sine alpha will be useful to us, as we've seen. So we express this in terms of sine alpha or sine square alpha. And we are going to make use of this particular identity. Now, cos square alpha or cos square theta is equal to what? Is going to be equal to 1 minus sine square alpha. So when we introduce that here, we have that cos 2 alpha will be equal to 1 minus 2 sine square alpha. Of course, you can explain or you can work out this. And so we have that sine square alpha, just making this subject of this formula, we have sine square alpha is equal to 1 minus cos 2 alpha, and it's all divided by 2. Now, why is this going to be useful to us? Remember what I tried to show from here, or what the thinking we worked with before we got here. Now, our alpha would be equal to 22.5 degrees, and our 2 alpha would be equal to 45 degrees. And because it's easier to work with 45 degrees, so we can do this. We've successfully expressed sine alpha in terms of cos 2 alpha, which is something we can work with. And so we have that sine square alpha is equal to 1 minus cos 2 alpha. Now it's cos 45 degrees. Sorry. Now that's cos 45 degrees all over 2, which is 1 over 2, 1 minus cos 45 degrees is 2 over 2. And now that gives us 1 over 2, which is 2 minus 2 over 2. which is 2 minus root 2 over 4. But recall that this is just sine square alpha, and we need sine alpha, which is sine 22.5. So we'll take roots of both sides, and so sine alpha, which I should write as sine 22.5 is equal to square root of 2 minus root 2 over 4, which will give us square root of 2 minus root 2 all over 2. Now this is done. Alright, so we go on to 2b, to evaluate 2b. Now we want to evaluate sec 300 degrees. Now recall first of all that sec 300 secant is 1 over cos. So sec 300 is 1 over cos 300 degrees. Next we look at the quadrant. Now realize that 300 is in the fourth quadrant. And so we can rewrite this as 1 over cos 360 degrees minus theta. But our theta that will give us 360 degrees. And then the purpose of expressing it in this form is so that we can use the definition that tells us that this is exactly same as cos 60 degrees. Now, recall that this is positive and not negative, and that's because cosine is always positive in the fourth quadrant. And so you can go on straight to evaluate. Cos 60 degrees is 1 over 2. So we have 1 divided by 1 over 2, which gives us 2. And so sec of 300 degrees is equal to 2. Then we move on to the third question, question number 3. Now question number 3, we are told that sine theta is equal to 7 over 13. And we have to use this given identity to evaluate the rest of these. Now, there are several ways you can go about it. You can decide to draw your triangle and then use Pythagoras to get the third part. But I think the best thing to do in this case, and also considering your exam situation, is realize that sine square theta is equal to, that's the square of this, that's 49 over 169. And so cos square theta from the first identity which I pointed out here and which I also asterisked because it's very useful, is going to be 1 minus sine square theta, which is 1 minus 49 over 169. And of course, you can tell that this is equal to, do I have 120? 120 over 169. Right. And so it means that cos theta, which is the square root of this, is going to be square root of 120 over square root of 169, which we have to be 13. And we can break this down further, or let's leave it as it is. So we can work faster. So we already have A. A is cos theta. Then B we are to obtain sine 2 theta. And I've also mentioned here sine 2 theta is 2 sine theta cos theta, which is 2 sine theta cos theta. And we have sine theta to be 7 over 13 as given, and cos theta to be root 120 over 13 as given. And so this should give us something somewhere around 14 root 120 over 169. You should look for your answer. In the options, it might have been further simplified, it might be just like this. C. Now 3c, we are to obtain tan 2 theta, tangent of 2 theta. And we recall that tan of 2 theta is equal to sine of 2 theta over cos of 2 theta. So we have sine 2 theta. So we just have to obtain cos 2 theta. Now we can also use the identity we have, and we know that cos 2 theta is equal to cos square theta minus sine square theta. And what is our cos square theta? Our cos theta is root 120 over 13. So cos square theta would be just 120 over 169. Then our sine theta was given 7 over 13. So our sine square theta would be 49 over 169. And so when we evaluate this, so I have this and this over 169. So this is our cos 2 theta. Tan 2 theta to be equal to sine 2 theta, which is 14 root 120 over 169 dividing cos 2 theta, which is 71 over 169. And by the time we evaluate this, we will be working around 14 root 120 over 71. Now we have to think smart, work smart. And so we move on to question 4. Now question 4 tells us to convert. So we are converting, we are doing conversion. Now we convert with this, converting from degrees to radians or radians to degrees. They are all measures of angle. And so we know that 2 pi radians is equal to 360 degrees. That's a complete revolution. In radians is 2 pi radians, and in degrees is 360 degrees. And so we can make our conversions from this. So this tells us that 1 radian is equal to 180 over pi degrees, and 1 degree is equal to pi over 180 radians. And so A says we should convert 9 over 5 pi from radians to degrees. Now, if 1 radian is 180 over pi, then 9 over 5 pi radians should be equal to 9 over 5 pi multiplying 180 over pi. Working with degrees, pi takes care of this, and then 5 takes care of this. We have 3 here, we have 6. And so this gives us, this is 54, 5, this is 27, and this is 32, 324 degrees. All right, and then B, we have to convert from degrees to radians. Okay, let's solve this question over at the other side. So we are evaluating for B. So we have to convert 300 degrees to radians. And we know that 1 degree, as we've stated there, is equal to pi over 180 radians. And so we have 300 degrees will be 300 multiplied by pi over 180 radians. And that gives us, take care of this. And then we have 6 here, 3, 6 is 5, so we have 5 over 3 pi radians. So that has been evaluated. I'll take our last set of questions. Question 5. We have to, so the last set of questions rather gives us, we have sin theta over 1 plus cos theta, and that's plus cos theta dividing sine theta equals cosec theta. Now we have to show this. Now, of course, we have to start from the left-hand side because there are a lot of operations to do here rather than just this singular identity. So we take the LCM on this side. That will give us sine theta multiplying 1 plus cos theta. Then doing what to do in LCM, we have sine square theta plus cos theta plus cos square theta. Now, recall that this is sine square theta plus cos square theta. Remember our general identities, which we have here, that is equal to 1. So we have 1 plus cos theta all over sine theta multiplying 1 plus cos theta. Now we have this here and we have it here, and of course you know that they would cancel out, and so we'll be left with 1 over sine theta, which is equal to cosec theta. And so we have proved this identity, or we deduced it as we were asked to. And finally, 5b, we have to simplify sine theta tan theta minus sec theta. So we are simplifying. We don't know what the end point is, but we have to bring it to a point that is, especially where it cannot go further down. So just break every compound identity. So we have sine theta multiplying tan theta, which is sine theta over cos theta, then minus sec theta, which is 1 over cos theta. So this gives us sine square theta over cos theta minus 1 over cos theta. We have the common denominator, so we have cos theta, then this is sine square theta minus 1. Now we realize that this looks like something we know, something we encountered before, and I bet you what that looks like is 1 minus sine square theta. But what we have here is sine square theta minus 1, so we can ensure that we have not changed it by putting the minus outside, and then this gives us over cos theta as before. So we have minus, this is the expression for cos square theta. So minus cos square theta over cos theta, and so this gives us minus cos theta, and this is very simple, so we've simplified that. Please subscribe, like the video, and share. Thank you.